Hello, good evening, everyone. You can unmute yourself and say, hello. Is my voice clear? Someone please confirm. Hello. Hello. Is my voice clear? Hi, everyone. Okay. So you can talk if you want. I hope we'll be having a discussion and not just we'll chat and I'll keep saying and saying and saying. Instead, let's have something to discuss. Okay. So if you were not there for the last two lectures, so I hope you got the recording. So for that recording, I hope you have gone through the recording. Okay. So if you have gone through the recordings, then we had started with properties of ITF, inverse trigonometric function. So we had completed till set 3 and this is the set 4. I am divided into total of 6 sets. So we had completed last time up to set 3. And we also done some questions. Now let's move on to set 4. So set 4 properties is very interesting and very easy to understand. Basically, if you know the trigonometric properties means like sine of minus theta is minus sine theta, cos of minus theta is plus cos theta, that way. So you can relate to you can relate these properties with the trigonometric. So let us start with set 4, which has the same. I said, suppose I want sine inverse of minus x. So basically the minus comes outside and it becomes minus sine inverse of x. Now in trigonometry, if you know inverse trigonometry, we had divided domains and principal value range into two parts, like for sine inverse, cosec inverse, and tan inverse. These three had PVR, principal value range from minus pi by 2 to pi by 2, means first and fourth quadrant. And for cos inverse, sec inverse, and cot inverse, they had their PVR in first and second quadrant. So accordingly, all the properties are also the same. Like if one of the formulae for sine inverse is given, similar formulae will be there for cosec inverse and tan inverse. And one of the formulae for cos inverse is given, similar formula will be there for sec inverse and cot inverse. As you can see here, in case of sine inverse of minus x is equals to minus sine inverse of x. Same is for tan inverse. Tan inverse of minus x is minus tan inverse of x. And same is for cosec inverse. Cosec inverse of minus x is minus cosec inverse of x. So, and the other three, which are cos inverse, cot inverse, and sec inverse, they have cos inverse of minus x is pi minus cos inverse of x. Please note this, pi minus cos inverse of x. Similarly, cot inverse of minus x is pi minus cot inverse of x, and same for sec inverse of minus x. Sec inverse of minus x is pi minus sec inverse of x. Now, why this changes happens? This all happens because of the PVR. Since PVR of sine, cosec, and tan is in the first and fourth quadrant, meaning the angle means the output should be in the first and fourth quadrant. In first quadrant, we know if the angle is alpha, then the corresponding, angle in the fourth quadrant is minus alpha. Therefore, it just the negative sign comes outside in sine inverse, tan inverse, and cosec inverse. Similarly, for cos inverse, cot and second quadrant is pi minus alpha. So therefore, here comes pi. See pi minus, pi minus, because we want the answer in the second quadrant. So I hope this is easier to remember for you all. This will make it very easy to remember this formula. So let's move on to next. How to use this property? How to use this property? So how to use this property is very simple. Suppose let's take an example. I will take an example. Suppose someone asks me the value of sine inverse of minus half. So what we can do by using the first property, sine inverse of minus half, I can write it as minus sine inverse of half. I can write it as minus sine inverse of half by using the first formula. Now, as you all know, sine inverse of half means what angle will sine inverse of half give? It will be in first quadrant and it will be 30 degrees. So my answer will be minus 30 degrees, or we can write it in radians as minus pi by 6 radians. So the use of this property is very simple. It just helps us to find the answers where negative values are involved. So let us look at some examples and some questions so we will know how to use this property. So next, here are the set of questions. Now, if we, the set 1, 2, and 3 of the properties, we know that we actually don't like the other trigonometric functions. Other trigonometric function means cosec, sec, and cot. We are generally more comfortable with sine, cos, and tan. I personally am very comfortable with sine, cos, and tan. So I usually avoid dealing with cosec, sec, and cot. But here in this, we have cot and sec. So if you know the set 3 says that, let me again revise it for you. So cot inverse of some value, suppose let's say x, can be written as tan inverse of reciprocal of that value, 1 upon x. So here I can write cot inverse of minus root 3 as tan inverse of reciprocal of minus root 3, which is minus 1 upon root 3. And now if we use set 4, like tan inverse of minus, the minus comes outside. So I will get minus tan inverse of 1 upon root 3. So here it helps us in dealing with negative numbers. Now we all know tan inverse of 1 by root 3. Which angle of tan gives a value of 1 by root 3? It is 30 degrees. So 30 degrees means pi by 6 radians. So my answer is minus pi by 6 radians. Okay. If you have any doubts till now, you can ask. Please don't be shy. Let the section be more interactive. I hope you all are understanding this. Yes, no, then we proceed further. Hello. Is my voice clear? You can mute yourself, please. Anyone please confirm my voice is reaching you? Hello, yes, no. Okay. So I hope you are getting all this. let's move on to the next question. So the next question here we have sec inverse. Again, we know by reciprocal relations that sec inverse of any value means cos inverse of reciprocal of that value. So here for sec inverse of minus 2, I can write cos inverse of reciprocal, which is minus 1 upon 2. We see using this the set 4 property, it is very easy to deal with negative. And cos inverse of half. What angle of cos gives value half? So let me guess, I guess 60 degrees. 60 degree means pi by 3 radians. And what is pi minus pi by 3? Pi minus pi by 3 is 2 pi by 3. My final answer is 2 pi by 3. I hope this is very clear. If yes, we can move on to the next set of properties, which is set 6. Let me remind you, we have total 6 sets, out of which we have done in 4. So next one is going to be set 5. Now set 5 is a very interesting property. By looking at set 5, I need you to relate it with the square identities. Like sine square theta plus cos square theta equals to 1. 1 plus tan square theta equals to sec square theta. So these are basically like that. But here, inverse trigonometry is involved. Hello? Anyone saying something? Okay, let's proceed. Yeah. So in set 5, let me see what we have. The first says sine inverse of x plus cos inverse of x is pi by 2. Meaning if we add sine inverse and cos inverse for the same value, we will get pi by 2. Second says tan inverse and cot inverse is also pi by 2. Same is for tan cot and same is for sec inverse and cosec inverse. So if we add sec inverse plus cosec inverse, we will get pi by 2 for the same value of x. Now here, this, if you remember, this is the domain. What is the domain of sine and cos? It is from minus 1 to 1. What is the domain of tan inverse and cot inverse? It is any real number. And what is the domain of sec inverse and cosec inverse? It is less than minus 1 or greater than 1. So this is just for your reference. Here the domain is written. So how to use this property? This property says that we need pairs of trigonometric function. Which pair do we need? We need sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. So if in a question we see, yeah, we can modify into these pairs, we can easily use this property. So let us look at this example here. We have cos inverse of something plus cos inverse of something. If you can relate this, cos inverse means there is cos inverse in first formula. So we can easily use first formula. So this is my hint. If I get sine inverse, I can use sine inverse plus cos inverse equals to pi by 2. So if I can get sine inverse, you please listen to me very carefully. If I can get sine inverse, so meaning I have cos inverse. Suppose I need to convert this into sine inverse because we need one sine inverse and one cos inverse. So I need to convert cos inverse into sine inverse. So which method do I use? We have done this before. It is called triangle method. If not, you do not remember, let us go through it again. What does triangle method mean? We use the, like we equate cos inverse of 3 by 2 concept, we can write cos theta is equals to 3 upon 5. Now by original definition of cos, what was cos? Cos theta was adjacent upon hypotenuse in a right angled triangle. So in a right angled triangle, if I take this angle as theta, then the adjacent side will be 3, hypotenuse will be 5. And if you know Pythagoras, the opposite side will be 4. So opposite side 4, adjacent side and hypotenuse. So what we wanted to convert cos inverse into sine inverse. So we need to write sine theta. Sine theta is basically opposite upon hypotenuse. What is opposite? Opposite is 4, hypotenuse is 5. But do we want sine theta or sine inverse? We want sine inverse. So again, we will use here by inverse trigonometry, theta will be equals to sine inverse of 4 upon 5. So by equating these two equations, we can write cos inverse of 3 by 5 as sine inverse of 4 by 5. Cos inverse of 3 by 5 as sine inverse of 4 by 5. So here, if I input this in a question, my question will become sine inverse of 4 by 5 plus cos inverse of 4 by 5. Now, if you can observe, we got this first formula where in place of x, we have 4 by 5. So if sine inverse of x plus cos inverse of x, both the x are same, then we can write it as the answer is pi by 2, meaning 90 degrees. I hope this is clear to you all. Okay, so we are done again with set 5. Set 5 property. Please remember there are 3 formulae with 2 pairs each. Sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, and cosec inverse. Now let's move on to the last property, which is the most important of all. It is asked many times in geometry. So 3 formulas: first, second, and third. And these 3 formulas are for tan inverse. Like first and second is addition of 2 values of tan inverse of x plus tan inverse of y. Second is also tan inverse of x plus tan inverse of y. But their formulas are different depending on the values of x and y. So if my x and y both are positive, means greater than 0, but their product xy is less than 1, then I can write tan inverse of x plus tan inverse of y equals to tan inverse of x plus y upon 1 minus xy. So I would like this to relate to compound angles. If you know tan A plus B, this is similar to tan A plus B. Tan A plus B, the same was tan A plus tan B upon 1 minus tan A into tan B. I hope this is clear. So you can see the relation x plus y upon 1 minus xy is similar to this tan a plus tan b upon 1 minus tan a tan b. So it will not be like difficult for you to remember this formula. You just have to make sure you remember these conditions. The condition 2 says x and y are again positive, but the product xy is greater than 1. So the condition is mainly for the products. In the first, we have product xy less than 1, and second, we have product xy greater than 1. So if the product xy is greater than 1, then the formula just adds pi. We will just get pi plus. Okay, I hope this is clear. And the third one is tan inverse x minus tan inverse y, where there is no condition on x and y. So we can use for every value of x and y. So tan inverse of x minus tan inverse of y is tan inverse of x minus y upon 1 plus xy. Let me tell you, this is similar to tan a minus b. Tan a minus b was tan a minus tan b upon 1 plus tan a into tan b. So I hope this is clear to you all. There is one simple, very simple example for use of this property. And after this, we will do questions I have selected. They are also they also appear, some of them in previous year JEE. 2-3 questions are there from previous year JEE. So let's look how to apply this formula. So as we can see, it is addition of two tans. Tan inverse of x, suppose x plus tan inverse of y. Meaning I can use first formula or second formula depending on the condition of x and y. Here you can see x and y both are positive, but if we take product x into y, we will get 1 by 2 into 1 by 3, which is 1 by 6, which is less than 1. And if the product xy is less than 1, we have to use the first formula. So I can write this as tan inverse of x plus y upon 1 minus x into y. So this will be tan inverse of, if you can take LCM, the whole upon 1 minus 1 upon 6. So what I'll get from here? I will be getting tan inverse of 5 by 6 upon, here also if we take LCM, we will get 6 minus 5, which is 5 by 6. So these all will get cancelled and will be left with very beautiful number, which is tan inverse of 1. What is tan inverse of 1? 5 by 4 or 45 degrees. So I hope the application of the formula is very clear to you all. If it is clear, we can now move on to next. Like we have done covered all the properties of which the main properties are secant, Z2 and Z6, because these are the properties from where most of the questions come. So now let us look at some questions and how to deal with it. So yeah, prove that. Here the next question is prove that. So we have to prove sine inverse plus cos inverse is sine inverse of 56 by 65. So as you can see here, that sine inverse and cos inverse are getting added. So you might think this property phi, set phi. But remember, set phi, both the values should be the same. Here both the values are different. And sine inverse and cos inverse are getting added. So let me tell you how to approach this question. We will first convert sine inverse and cos inverse into tan inverse. Now here again we look at we have to convert sine inverse to tan inverse, cos inverse into tan inverse, meaning we have to use the triangle method. So if I take sine inverse of 3 by 5 as alpha, then I can write sine alpha 12 on 13. 13. I hope this is clear. Now sine is, let's make a right angle triangle. Here angle alpha 90 degrees. Sine is opposite upon hypotenuse. If you use Pythagoras or if you are familiar with the Pythagoras triplets, then here it will be 4. And if we make triangle here for the angle beta, cos is adjacent upon hypotenuse. And if you use Pythagoras, we will get 5. We wanted tan. So tan alpha will be opposite 3 upon adjacent, which is 4. Similarly, tan beta will be opposite, which is 5 upon adjacent is 12. So here I do not want tan alpha, I want tan inverse. So I can write alpha is equals to tan inverse of 3 upon 4. Similarly, I can write beta is equals to tan inverse of 5 by 12. So if we equate these both, that means in place of sine inverse of 1 by 5, I can write tan inverse of 3 by 4. So my question, or let me say my LHS, left hand side, will be tan inverse of 3 by 4. Similarly, I can write cos inverse of 12 by 13 as tan inverse of 5 by 12. This is a very good example for the last set of properties, which was tan inverse of x plus tan inverse of y. Now, there were two conditions. Product should be less than 1. If you do product x into y, you can check it. It will come less than 1. So, if it is less than 1, the formula will be first one, which is tan inverse of x plus y upon 1 minus x into y. I hope it's clear. So let us take LCM here. We will get tan inverse of what will be the LCM? 12 is the LCM and 3 is the 9. I hope I am right. Multiply divided by 3. Yeah. So we will get 9 plus 5. What we will get in denominator? We will get 1 minus 5 3 are 15. So we can cancel this now, right? Okay. No need to cancel. We will just 15 upon 48. So now if we take the LCM, we will get tan inverse of 13 by 12. And if you know our denominator will get reciprocal, means we get 3. This is very simple. 12 ones are 12, 4 are. So I get tan. I didn't make a mistake, right? I think I made some mistake here. Okay, could you find anything? Did I make a mistake somewhere? Hmm. Oh, yeah. 9 plus 5 is 14, not 13. Got it. Here it will be 14. But that doesn't. 9 plus 5 is 14. Chalo. You can see in right hand side we want sine inverse, but we have tan inverse. Means again we need to convert tan inverse to sine inverse. Means we need a triangle. So let me make a triangle for this. Tan is opposite upon adjacent. So means 56 and 33. When you use Pythagoras, let me tell you the hypotenuse will come to 65. We want tan inverse to be converted to sine inverse. So I can write equal to sine inverse. What is sine inverse? Opposite upon hypotenuse. So for this angle, opposite is 56. Hypotenuse is 65. So I'll get sine inverse of 56 by 65, which is equal to RHS. Hence, proof. So I hope you are getting this. This time, I didn't do all this procedure here. I directly made a triangle. This will help you to like with your speed. This will help with your speed. You don't need to do this anyway, as we are giving objective paper. We don't need to do this anyway. If you can do directly this, then it is better. It will save your time. So I hope this is clear. Let's look at the next question. Next question is evaluate. Evaluate means I need to find its value. Again, it is based on, let me tell you again, it is based on, if it is based on set 6, meaning I don't need cos inverse, I need tan inverse. So basically, again, we need to convert both this cos inverse into tan inverse. Means again, we have to make triangle. So let's make triangle for this and let's make triangle for this. So cos inverse is adjacent upon hypotenuse by Pythagoras. This will be 3. Similarly, here cos inverse is adjacent upon hypotenuse by Pythagoras. Thus will be 5. We need to convert cos inverse into tan inverse. So sine will be sine. I can write tan inverse. Tan inverse is opposite upon adjacent. Opposite 3. Adjacent 4. Adjacent 12. So this is x, this is y. You can check the product x, y is less than 1. Means we have to use the first sign of tan inverse of x plus y, 3 by 4 plus 5 by 12 upon 1 minus 3 by 4 into 5 by 12. Now, I hope you remember this calculation. It is exactly same as here. See, it is same. So don't mind me if I directly write it as tan inverse of 56 by 33. So I hope I can directly write it as sine of what it was 56. It is fine. I'm very bad at calculation, and unfortunately, you are also not helping me. So therefore, now let's see. Now it's time for us, since we need to find the value, it is time for us to use the second property. Second property, if you remember, says that sine of sine inverse of x basically is x. It's we can cut this. So if we want to use this second property, what we need to do? We need to convert this tan inverse again into sine inverse. So again, we have to make a triangle. Let's make a triangle here. For this, if I make a triangle, tan is opposite, sorry, this is adjacent, tan is opposite upon adjacent. So if you remember the last triangle, the hypotenuse will be 65. So I will get sine of, I need to convert into sine inverse. Sine inverse is opposite upon hypotenuse. Opposite is 56, hypotenuse is 65. Then by using this, I can directly cut. I mean, not it exactly doesn't sound mathematically correct to say cut, but we use it anyway. So we can write it as answer is 56 upon 65. So my value for the question is 56 upon 65. Let's move on to the next one. Next one is solving inverse trigonometric equation. Please see the heading solving inverse trigonometric equation. Now, to solve inverse trigonometric equation, or let me tell you to solve any equation, we basically need to the equation will have inverse trigonometric function. That is, it can have sine inverse, cos inverse, sine inverse, cosine, secant, cot. So basically, we just, what do we need? We need to use the properties to get the value. Now, first sum I have taken very simple for you all, because it is directly, what it is directly? Directly, property number 6. We can directly use tan inverse of x plus tan inverse of y. Now, you may have a doubt that which of the formula should I use. So let me clear that. If nothing is mentioned, we will by default always use the first formula. Here, since nothing is mentioned that if the product is less than 1 or greater than 1, we will by default use the first formula. But if you are really curious, if you are really attentive, you can say that this into this means 2x into 3x is basically 6x square will always be greater than 0. So we can use the first formula. So if I use the first formula, let me make it clear. Okay. If I use the first formula, I can write this equation as tan inverse of x plus y upon 1 minus x into y is equals to pi by 2. Now, if you see clearly, according to the inverse trigo definition, I can get tan inverse on that side. So I will get 2x plus 3x is 5x. On the right hand side, I will get 10 pi by 2 upon 1 minus here 6x square. If you remember, what is the value of 10 pi by 2? It is not defined. So basically, I got an equation 5x upon 1 minus 6x square is not defined. Now, if you remember some basic maths, any quantity which is in a fractional form, numerator upon denominator, when it gets not defined, that means the denominator is equals to 0. Any numerator upon 0 will automatically give us not defined. So by here we can use this, means this implies 1 minus 6x square is 0. So if 1 minus 6x square is 0, I will get 6x square as 1. I will get x square as 1 upon 6. Implies what is the value of my x? It is plus minus 1 upon under root of 6. Okay, but yeah, it's fine. X is equals to plus minus under root of 6. So I hope this is clear to you all. Clear or not? Right, right, right. I hope it is clear, clear. Okay. Should I move further? Okay. Okay, wait. I am sorry, I was not reading the chat. What is the difference between one and second equation? Okay. So I think you are asking about this first and second one, right? I think you are asking this first and second one, right? Okay. So there is difference of pi. See, pi plus. The formula is same. This value is same, but there's only difference of pi plus. It comes because of this condition. Here xy, the product is less than 1, and here xy is greater than 1. So we have to first check if xy less than 1 or xy greater than 1, and accordingly we have to use the formula. I hope this is clear, right? Okay, yes, yes, sir. Okay, fine. I guess you are more comfortable in chatting. You can unmute your mic and say, please. So let's move on to the next question. Okay, chalo. So if I see the next question, it is this one. Again, what formula do you see? X plus 10 inverse of y. So this is x, this is y. So as I told you, if there is no information on the product, we can by default use the first formula. There is no need to check of y. I will get tan inverse of x plus y. So x minus 1 upon x minus 2 plus x plus 1 upon x plus 2. So before this, okay. Let me make it the calculation. Let me make it more simpler. As you know, the formula is x plus y and x into y. So before inputting in the formula, let us just calculate it first hand. So what will be x plus y? It will be x minus 1 upon x minus 2 plus x plus 1 upon x plus 2. So what will get if I take LCM? I'll get x minus 1 into x plus x minus 2 upon x minus 2 into x plus 2. If I open the bracket now, I will get x square. If I open this, I will get plus x minus 2 plus. Here I will get x square minus x minus 2. I hope it is right. Minus 2x plus, yeah. Upon niche we have a plus b into a minus b, which is a square minus b square. So from plus x minus x cancelled. So upper will get x square plus x square, which is 2x square, and minus 2 is minus 4 upon x square minus 4. So this is the value of x plus y. Now, what is the value of x into y? Let us check. So x into y will be x minus 1 upon x minus 2. X a minus b plus b, which is x4. Now we want 1 minus 1 upon x square minus bracket x square minus 1 upon x square minus 4. So here x square minus x square gets cancelled, square minus 4. So let us input this in the formula. So my equation will become tan inverse of, what was the formula? X plus y upon 1 minus x into y. So I will get tan inverse. What was x plus y ka value? X plus y ka value was here, this one, which is 2x square minus 4 upon x square minus 4 upon, what is 1 minus xy ka value? It is minus 3 upon x square minus 4. So as you can see, x square minus 4, x square minus 4 will be cancelled. Okay, and this is equal to pi by 4. So according to inverse trigonometry definition, I can get tan inverse on that side. So I'll get tan pi by 4, and here I will get 2x square minus 4 upon minus 3. And what is the value of tan pi by 4? It is tan 45, which is 1. So my equation will look like, it will be a quadratic. I will cross multiply minus 3. I will get 2x square minus 4 is equals to minus 3. Meaning I'll get 2x square is equals to, I'll send 4 on the other side, I'll get 1. So I will get x square is equals to 1 upon 2, meaning x will be equal to plus minus 1. It was very simple, algebra. Okay, let's now see the next question. Next question is again pi tan inverse of x plus 3 cot inverse of x equals to 2 pi, meaning I need to find the value of x. Now, here it is important. As you can see, we have tan inverse and cot inverse. If you remember the fifth set, we had two pairs, sine inverse plus cos inverse, sec inverse plus cosec inverse, and tan inverse and cot inverse. There also I told you to keep in mind, I hope you remember. If you get to see these two pairs, what can I do? I can use those formula. So I use tan inverse of x plus cot inverse of x is equals to pi by 2. Meaning I can write cot inverse of x as pi by 2 minus tan inverse of x. So if I use this and substitute it here, my equation will look like 5 tan inverse of x plus 3 bracket pi by 2 minus tan inverse of x. If I open this, I will get 5 tan inverse of x minus 3 tan inverse of x, which is 2 tan inverse of x plus 3 pi by 2. And what was on the right side equals to 2 pi equals to 2 pi. So from this, I will get 2 tan inverse of x is equals to 2 pi minus 3 pi by 2. Can you calculate it? 2 pi minus 3 pi by 2, which is, I guess, pi by 2. Now, if I send 2 here, my equation will become tan inverse of x equals to pi by 4. Now, according to inverse trigonometry, I can write x equals to tan pi by 4. We get very x equals to 1. I hope it is clear. The main part was to click this property, because this property is very tough to use. Like in some if comes, there is only one it, that is the best. If we get to next question, use of plane trigonometry. Here, use of plane trigonometry, let me tell you, many questions of inverse trigonometry can be solved by using plane trigonometry. Now, how to use plane trigonometry? Plane trigonometry says that assume one of the inverse trigonometric function is theta. What does it say? Let one of inverse trigonometric function be equal to theta. If one of the inverse trigonometric function is equals to theta, then we can use plane trigonometry. Let us see here in this example. Here we can see tan inverse of 0.5. So there is only one trigonometric function, inverse trigonometric function here. So we assume that inverse trigonometric function tan inverse of 0.5 means half as theta. Now by plane trigonometry definition, I can write tan theta is equals to half. Let me put this equation as 1 and substitute this value in the question. If I substitute this value, what I'll get? I will get sine 2 theta. Sine 2 theta. Now, if you know the multiple angle formula of sine 2 theta, it is 2 tan theta upon 1 plus tan square theta. And to your surprise, we know the value of tan theta. So we just need to substitute it here and we get our answer. my answer will be 2 into tan theta upon 1 plus square, means 1 plus 1 by 4. It will get cancelled. So I get 1 upon 5 by 4, which is equal to 4 upon 5. See, it becomes very easy as we are more familiar with plane trigonometry. So if you can, you should use plane trigonometry, or else you can also use the properties. So let us look at one more question, last question for today. I hope you are all getting something from this lecture. Yeah. The solution of this. Now this is an equation. Let me tell you what that if to use plane trigonometry, let one of the inverse trigonometric function be theta. As you can see here, the inverse trigonometric function is sine inverse of x. So let sine inverse of x equals to theta. Then by definition, I can write x equals to sine theta. So if 2 theta is equal to 1 angle, if we convert the question from inverse trigonometry to plane trigonometry, now my question is converted into plane trigonometry. We need to know the formula for plane trigonometry. So cos 2 theta equals to 2. I hope you remember what is cos 2 theta equals to 1 by 9. So cos 2 theta is 1 minus 2 sine square theta is equal to 1 by 9. And to your surprise, we know that. So let's substitute. I will get 1. If I cross multiply, I will get 9 minus 18x square is equals to 1. This is the quadratic. If I rearrange it, I will get 18x square is equal to 8. Right? I hope there is no mistake here. Yeah. So I can write x square is equals to 8 upon 8. 18. Yeah, is my voice clear? Okay. Let's continue this. What I will get, I will get square root. If I take square root, I will get x equals to plus or minus 2 by 3. So what option is this? It is option C. X equal to plus minus 2 by 3. It is option C. So this way we can use plane trigonometry. This way we can use plane trigonometry. Okay, we'll go through the question one more time. I guess there is some, wait, 1 second. Okay, we'll go through the question one more time. Let's see this. Inverse use of plane trigonometry suggests that we use plane trigonometry. How to use plane trigonometry? We use plane trigonometry by assuming one of the inverse trigonometry function as theta. So here in this question, there was inverse trigonometric function sine inverse of x. So we assume that inverse trigonometric function sine inverse of x as theta. Now by definition, if I can write x equals to sine theta. So these are my two equations here. If I substitute this in the question, I will get cos 2 theta is equals to 1 upon 9. Now, we have to use a formula for multiple angles for cos to theta. If I use a formula and if you know cos to theta equals to 1 upon 1 minus 2 sine square theta. So 1 minus 2 sine square theta I used. So I will get 1 minus 2 sine square theta equals to 1 upon 9. And to your surprise, sine square theta value you already know. Sine square theta value is x. So I just substituted the value there. So I get 1 minus 2 x square equals to 1 by 9. After this, it is very basic algebraic manipulation. As you can see, cross multiplied 9 and got a value of x. Just don't forget, whenever we take square root, we use a plus minus sign. So here x value is plus minus 2 by 3. I hope it is clear now. So that is option C. So these are the questions. Out of these, two of them, which is this one, and the were asked in J mains for the use of plane trigonometry. I hope it is clear to you all, because from next time means from tomorrow, we are done with inverse trigonometric function. We will be starting with a very interesting chapter and the basis of calculus. It is called limits. So we'll be starting with limits. We will understanding what is limits and how all it is from tomorrow. I will give you the introduction and all. We'll start with limits from tomorrow. If you have any doubts in trigonometry, you can ask me. Your doubts, and then we'll move to the next part. I hope this is all clear. So we will leave here. Actually, I introduced myself in the first lecture, but you are not present. So let me just introduce myself again. My name is Keval, and nice to meet you all. I just have one request from you all: ki you please talk to me. Otherwise, I get bored easily. You know, as like you also get bored if you don't like talk or just listen carefully. So you just talk to me, yes sir, no sir, anything you want to ask. Avoid typing in the chat. You can unmute yourself and talk. Okay. Now from tomorrow, we'll start with again limits. So that's all from my side. Okay. Take care. Bye bye. Meet you tomorrow.